everyone, welcome to BYJU'S exam prep. Hope you guys are fine. So in today's session we'll be talking about hydrology and irrigation questions, that is concept through questions. So guys, come on, join the session fast so that we can start it ASAP. Let's be quick. Let's be quick so that we can start it as early as possible. So let me tell you a few things before we proceed. There's a free workshop if you guys are planning for GATE 2024. So what should be your 1 year preparation strategy? All these things will be discussed by Rakesh sir on 26th March at 12:30 p.m. Okay guys, so you can attend this workshop for sure. Next, coming further, you can join my Telegram group for upcoming vacancies and for all the quiz and everything. Okay, now let's talk further. GATE preparation ebook link is in the description. You guys can join it. And so I guess now maximum students have come. So shall we start, guys? Shall we start now? Shall we start the session fast? Okay. So let's start the session fast. Okay. So if I talk further, so we'll be talking about the basic and the important questions regarding hydrology and irrigation. Those topics which you have seen that frequently questions have been asked from that topic in BARC, or if you are talking about any other competitive examinations. We'll keep the target that within 30-35 minutes we are able to solve the questions. Okay, Rajesh. Fine. So let's start the session. Okay. So this is the first question, and this question is regarding recuperation test. So I guess you guys remember the formula, because here along with the question you need to remember the formula, or even you can do the derivation, but it's the wastage of time if you are doing the derivation right now. So it's good if you remember the formula. A recuperation test is conducted in an open well by depressing the water level by 2.7 meter, and after 90 minutes that water level again comes back. So it's like, I'm drawing it with the free hand. So it's like if the drawdown initially was 2.7 meters, initially if it was 2.7 meters, in 90 minutes the water level came back. Okay, it was came back by 1.7 meters. So if this is S1, S2 will be 2.7 minus 1.7, that is it will become 1 meter. So technically they have given both S1 and S2. Good evening, Arun. Now you have to calculate the yield. Yield means you have to calculate the discharge. What is the formula for discharge? Discharge is CAS. Now what is the formula for specific yield? This is, I'm taking base 10. That's why I'm writing 2.303 log base 10. Area into the depression head. Okay. Now, how much time they have told you in the question? They have told you 90 minutes. So, converting it into seconds, log base 10. S1 is 2.7, S2 is 1. Area, you will take it how much? How much is given to you? How much is given to you? Diameter is given to you 3.2. So, pi by 4, 3.2 square, and depression is 3.7. You will get the answer in meter cube per second. You know 1 meter cube is equal to 1000 liters. Multiply by 1000, you will get the answer in liters per second. How much you guys are getting? How much you are getting in liters per second? Just check it out whether it is 5.47 or on everybody else. Just do the calculation. Check it out. Is it coming 5.47? 5.7. Correct, go. Okay. So this was the first question. Coming to the next question. Yeah. Here's the question. Rainfall in 3 consecutive hours is given to me. That means indirectly they have given the rainfall intensity. For the first hour it is 3.5 centimeter per hour. Then 4 centimeter per hour. Then 3 centimeter per hour. Horton's equation. That means technically they have given you this value. Okay. Now in the question it is asking you to calculate the runoff. You know, runoff is total how much precipitation occurred minus infiltration. That will give you what? Total runoff. टीडीए जी में नहीं है, अच्छा जेई में नहीं है, ओके कोई बात नहीं, बार्क में तो है, बार्क इन देर, सीआरबीआई में भी है, सो मैक्सिमम में है, इसलिए हम लोग ये कर रहे हैं. ओके ओके फाइन. सो नाउ यू आर नॉट प्रिपेयरिंग फॉर बार्क एंड ऑल अरुण. चलो, तो ये हो गया. अब in this question we have to calculate infiltration. That is the only logic. But I don't know, you know this thing, that this Horton's equation you will be able to apply only when intensity of rainfall is greater than or equal to infiltration capacity. So first you have to check at what point intensity of rainfall becomes more than infiltration capacity. Okay, so what I'll do, you could substitute t is equal to 0 and check it out. I know that it will be less than this centimeter per hour because per hour rainfall is given to you. So from here you will calculate what? The value of t. Come on guys, calculate the value of t from here. It will be e to the power minus 2t 3.5 minus 0.9 divided by 3.8. How much it is coming? How much it is coming? 3.5 minus 0.9 divided by 3.8. It comes out to be 0.684. Now take log on both sides. When you will take log on both sides, divide by 2. This will come out to be 0.1897. So up to 0 to 0.1897 hours, intensity of rainfall is less than the infiltration capacity. After that, you can apply Horton's equation. So 3.5, I'll go for the other page, 3.5 centimeter per hour. This rainfall was going into the infiltration for how much hours? 0.1897 hours. Excuse me. After 0.1897 hour to 3 hours, you will apply Horton's equation. Come on guys. Now you have to integrate. I expect that you guys should be very good in integration so that you can omit the steps and don't waste your time. Like I know integration of 0.9 t will be t. So I could just directly write it like this. Integration of this will be e to the power minus 2t will be e to the power minus 2t divided by minus 2. So here it will be come on. So this will give you the value of infiltration. Are you guys calculating? Anybody? Are you guys calculating the value? Just do it once. You have to just substitute it. How much it is coming? Anybody did it? This comes out to be 4.489 centimeter. Just check it out once. So this is the total infiltration. In the question it is asking me runoff. Runoff is what? Runoff will be the total precipitation minus infiltration. Precipitation 3.5, then 4, then 3, minus infiltration is 4.489. So this will give you how much it is coming. Just check it out how much it will be coming. The runoff will come out to be approximately 6.01 centimeter. Okay, so yeah, these questions are lengthy. So if such questions comes, I'll advise you that first try to solve simple, easy calculation questions and then set it for mark for review and go afterwards and solve these questions. Okay, coming to the next question. A 6-hour event occurred over a catchment of 1.8 kilometers square. Total observed rainfall is given to you. Infiltration at the start is given to you, and infiltration after 3 hours is also given to you. So it is asking you what will be the runoff. Here you have to take the factor of evaporation also. Everything is given to you. Here one more thing is there, that here you have evaporation. So pan coefficient is also given to you. So how you guys will proceed for this question? Come on guys. You know FC, F naught minus Fc e to the power minus kt. This is the formula. So we'll just integrate it. What is Fc and what is F naught? If you talk about Fc, this attains a constant value, that is final infiltration is 0.5, which is given to you. Initial infiltration which is given to you in the question. कितना दिया है question में? Initial infiltration 2 centimeter per hour. Final is 0.5 e to the power minus kt dt. So you will integrate this 0.5 plus 1.5 e to the power minus 5 dt. For how many duration you have to do it? For 3 hours. So guys, that is pretty simple. What you can do? मैंने पहले भी बोला, you have to be so pro that you don't have to waste your time in integration. See, in a single step I am doing it. Just substituting the unit in a very single step. So this you should also train your mind that you should be able to do partial calculations in your mind, so that 2-3 steps you are able to skip it and you should be able to do it. So with this you will be getting the infiltration. How much is the infiltration, guys? Go through the calculations once. I'm telling you the concepts, but I expect that calculations you guys will be doing it. So this is the infiltration which is given to you. I have to know the total rainfall, which is 24 centimeter. So 24 centimeter is the total rainfall. Out of that, 3.3 centimeter is the infiltration, and evaporation is also taking place. How much? 0.8 centimeter. But this is from the pan. For getting the lake evaporation or evaporation from that catchment, multiply with the pan coefficient. How much it will be coming? 20.14. Go check the calculation once. That I can expect from you, that you guys can check the calculations. Okay. So this is the question. Next coming further, we have the questions regarding estimation of missing rainfall data. Okay, generally we don't give importance to this topic, but this topic also can be asked. So now talking about here, the normal rainfall at 5 stations is given to you. In the year 1989, T was not working, other stations were working, so you have to report the rainfall at station T. So whether to go by arithmetic method or normal ratio method, first you have to check it out. So which was missing? T was missing. What is the rainfall at T? Normal rainfall 63.7. So you will take 10% variation and see whether all the others falls into this category or not. So 57.33, 70.07. So you can see here 81.2, 72.3, 89.4 are the ones which are out of this range. So definitely we have to go for normal ratio method. Simple as that. So precipitation at station T will be normal rainfall at station T. First I will take P. Now just substituting it. Normal rainfall at T was 63.7. How many data we know? 4. 0.1. Just substituting it, nothing else. Oh yeah, the calculation will become tedious because you'll be using virtual calculator. That is the only thing you have to make sure. Other than that, no issue. And check it whether the data which you are substituting, that data also is correct or not. Okay. PQ 79.89, 83.2. 63.7. Some data I missed. 69.4, 81.2, 89.72.3. This was 72.3. See, I told you now on substituting data, it might create issue. That is the reason, verify it and do it. Come on. What is the value of precipitation at station T? Let's be quick. This will be the precipitation. Okay, so this will be the answer. Simple questions. Remember the formula, that logic, that's it. Now, this is an MSQ. I created this because if I would have created it MCQ, everybody would have answered. So I created it MSQ. Come on, guys. Which of the following rain gauges are of recording type? So yes, when you talk about tipping bucket type, when you talk about weighing bucket type, when you talk about natural siphon type, these are recording rain gauges. So you will say B and C are correct. But here, Simon's rain gauge, you know that this is a non-recording rain gauge. Everybody knows about that. But telemetry is something which you guys have the confusion. So let me tell you that telemetry rain gauge is also of recording type. Okay, it is also of recording type. Okay, now this is regarding Mayer's formula. In gate, important for gate point of view, ESE point of view, for your BARC point of view also. Okay, yeah. Okay. BD, I told you it is MSQ. Why B and D? Why Suddhu Thakur B and Arun D? But I told you it is MSQ. So all the three are there. Okay. Now, talking about Mayer's formula. What is the formula for Mayer? You, instead of EW, you can write ES also. Nomenclature, that depends upon you, whichever you are comfortable. So Km constant value is given to you. Saturation vapor pressure is given to you, but actual vapor pressure is not given to you. So in place of actual vapor pressure, they have given you relative humidity. So how will you calculate? This is EA by EW, or you can say ES. EA will come out to be, how much it is coming? 15.9. So here 15.91 mm of Hg, 1 plus wind velocity at 9 meter above ground level. 1 meter above ground is given to you. You can go through this 1 by 7th power law formula. So U9, U1, 9 to the power 1 by 7, 1 to the power 1 by 7. So from here 6 into 9 to the power 1 by 7. How much it is coming? This comes out to be 8.212. So guys, substitute it here, 8.212. How much it will come? How much it will come? Will it come out to be 8.667? Just check it once. 8.667 आ रहा है? Come on guys, check it once. So this will be your answer. Calculation you guys can do. This much I can trust you guys. Okay. This is very simple question, yet important. Why? Because till now, whenever you see gate questions, nowhere they ask you basin loss is not given to you. But in this question, deliberately I added basin loss so that you could know that whether you have to include basin loss in W index or pi index, all that concept should be clear, and that's why I've included it here. So whenever in question they ask you phi index, first you have to calculate W index. So let's calculate W index. W index is average infiltration rate over the entire storm period. I have already told you in W index initial losses are not taken. Initial loss को हम नहीं लेते हैं. So whenever in the question if they are giving you initial loss, don't neglect that. See, if they are not giving you, assume it to be 0. But if it is given to you in the question, you have to consider it. It is very, very mandatory. So it's like precipitation minus runoff minus initial losses divided by the total time. Precipitation comes out to be 1.2 plus 4 plus 3. Runoff is 4 centimeter. Loss you have to subtract because W index does not take losses with it. So you have to categorically reject it. 6 hours, 6 hours, 6 hours, 6 hours. So this will become how much? This will become how much? 18 hours. How much is the W index coming, guys? How much it is coming? Is it coming 0.2? And phi index, average infiltration rate above which rainfall volume is equal to runoff volume. So you will take only those infiltration which produces runoff. Let me tell you, phi index is always greater than or equal to W index. Secondly, very, very important, phi index consider initial losses also in itself. W index rejects initial losses, while phi index tells you that fine, if there is depression storage, if there are initial losses, if interception loss, all these initial losses are considered in phi index. So guys, tell me, I'll check out this data. 1.2 plus 4 is 3. That's point 2 only. So we know that any data is given to you here. 0.2 centimeter per hour is the W index per hour. So for 6 hours, what will be the infiltration? 0.2 into 6, that is 1.2 centimeter. That means this data you cannot take. That means if in 6 hours 1.2 centimeter of rainfall was happening, all that was infiltrating. No, nothing was contributing to runoff, and so you won't be taking it in phi index. Second important thing is you will not be subtracting initial losses in phi index, because phi index ने पहले ही बोला है I will consider initial loss as infiltration loss. I'm telling you this thing's important more and more, because it can be asked in take the correct statement questions. W index, infiltration loss is subtracted. Phi index, W index, initial loss is subtracted, while phi index consider initial losses also as infiltration loss. Okay, because it is very, very difficult to measure initial losses like interception and depression storage quantitatively. Now coming to phi index, here we have precipitation which produces runoff, duration of rainfall excess. So you will take only 4 and 3. Runoff is 4 centimeter. We won't be subtracting basin loss, and hours will be 12 hours. How much we are getting? How much we are getting phi index, guys? Check it out. How much we are getting? 0.25 centimeter per hour. And conceptually, you can know also that whatsoever value will be there, it can't be 0.15. Why? Because phi index will be greater than or equal to. So one option you can reject it. Out of 3, if 3 option would have been less than 0.2, you wouldn't have to even calculate it also. But here, since 3 options are more than 0.2, you have to calculate it. Come on, guys. This you will be answering. This is a very simple basic question. This you guys will be answering. Come on. The Palmer index is used to express which type of drought? Which type of drought? Meteorological, hydrological, agricultural. Very good, Ayush. Agricultural drought. Correct. Okay. Now, this is very simple. The analysis of maximum daily rainfall on a city indicated that a depth of 280 mm has a return period of 50 years. So the probability of one day rainfall greater than 280 mm in the city will be occurring exactly 2 times in 15 years. So what you can say? 1 by T, 1 by 50. So it is occurring exactly 2 times in 15 years. So NCR, 15 CR, probability of occurring is 1 by 50. Probability of not occurring, the probability of occurring and non-occurring makes 1. So the non-occurring is 49 by 50. 15 minus 2, that is 30. How much it is coming? 0.032. Very good. Simple. Okay. This question. You have to calculate the frequency of irrigation. Permanent wilting point feed capacity is given to you. Consumptive use is given to you. You have to calculate the frequency of irrigation. So whenever you have to calculate frequency of irrigation, you need to know depth of water stored in root zone of crop divided by consumptive use. So here you have to calculate the depth of water stored. But only one thing which is there in this question, if 50% of available moisture is permitted to fall, that means field capacity minus optimum moisture content. This is the available moisture. Out of this, only 50% is permitted to fall. 0.50. Okay, in this question, optimum moisture content is not given to you directly, but indirectly they have told you that whatsoever is the available moisture is field capacity minus permanent wilting point. 50% of that is available to fall. Okay, so now you know dW is equal to gamma dd. That's it. Gamma d comes out to be how much? 1.5. This is 1. Depth of root zone is 0.9. Field capacity minus optimum moisture content will be 0.50 times field capacity minus permanent wilting point. How much it comes? How much it comes, guys? Try to solve it once. 0.081 meter. Check it Ayush once. This will be 81 mm. So you know dW is 81 mm and Cu is 5 mm per day. So how much is the consumptive use coming? 16.2 days, which you will take it, you will round it off to the lower side, because if you round it off to 17 days, in that small number of hours, it might possible that it may go to the permanent wilting point. After that, crop will dry up. What is this X here? Not talking about irrigation. The section marked as X in the gravity dam. हाँ 16 days ही तो बोला. ठीक ही तो बोला आयुष. गुड इवनिंग मैम, आई हैव सिक्योर्ड ऑल इंडिया रैंक 678 इन गेट इन. आपको 1 ईयर फॉलो किया और आगे भी करता रहूंगा. Many many congratulations Shriram. Yes, I remember your name beta. I guess you are preparing for IES also ना. AEC की भी preparation कर रहे हो ना. All the best for that also. Drainage gallery. चलो. इसको भी this conceptual question also. This conceptual question also, guys. Fast. इसका आंसर क्या है? आयुष, अरुण, दिव्यांशु, सबके सब, everybody. Consider the following statements regarding design of channel by Lacey as well as Kennedy. I guess ये तो बहुत easy है. Very easy. Very easy. Correct. So the theoretical concept of self transportation same in both the theories. Yes, Lacey is an improved version of what Kennedy's everybody know, because the canals designed by Lacey's theory failed. So Lacey's theory was an upgradation over Kennedy's theory. There are no defects in either of the theories false. Kennedy's theory was improved by Lacey's. Lacey's theories has also further defects. Any of you, if you also become like you go for PhD and all, you might change the defects of Lacey's as well. So 1 and 2, so A will be the correct. Now you have to calculate the exit gradient. The diagram is given to you. You have to calculate the exit gradient. H is 3.2. This is the downstream cutoff pile. Here you need to remember only the formula. That's it. That is what it is asking you in the question. 1 plus alpha square by 2. Alpha is B by D. Come on, elimination method से भी काम चल जाएगा. That option 3 is wrong. Yes, Ayush. उसी से ही basically चलेगा. Tell me. How much it is coming? Solve it and tell the exit gradient fast. I guess right now you guys are doing with the calculator. Who got the answer? मैं लिख रही हूँ, but आप एक बार ही check कर लेना. I'll also check it out once. .101 only. नहीं, 0.101 आ रहा है. Check it out. 0.101 ही आ रहा है. कहीं और तो कुछ नहीं. 40 divided by 4.5, 8.88, 8.89 लिया था. You also check your calculation once. Calculation is correct, beta. Okay. Now this question. A concrete dam is given to you. It holds 10 meter of static water, which you can see it here. Figure is not on scale. Uplift pressure is linearly. Okay. Full hydrostatic at the heel and 0 at the toe of the dam. So it's like this. Okay. Now, coefficient of friction is given to you 0.45. Specific weight of concrete and water is given to you. This diagram is given. There's nothing like they'll be asking difficult question. Okay. So here you have to calculate the width for no sliding condition. Come on, guys. I guess you don't have to do the you can say derivations and all. Simple, you can apply the formula. That's sufficient. Yes, this is the formula. H is 10, mu is 0.45, specific gravity is how much? Specific gravity is how much? Is it given to you directly in the question? How much is the specific gravity? We'll take it 2.4. How much it is coming? How much it is coming? Check it out once. Okay. Moving to this question. Simple question. Here actually this question is you should know the relationship between porosity, field capacity, unit weight of dry soil and unit weight of the water. So do you guys know the relation? You know this is important. I don't think that you should waste your time in derivation and all. This is gamma d by gamma w. Because in some of the cases they don't give you the unit weights, rather than they give you the porosity. So this is the formula. That's it. Nothing else you need to remember. That's it. Here they are asking you the depth of maximum available moisture. Every data, field capacity, permanent wilting point, root zone depth, everything is given to you. So you have to just calculate the depth of maximum available moisture. And let me tell you one thing. For calculating, this is very important. Whenever you calculate frequency of irrigation, there is no use of irrigation efficiency. So if in this question they would have asked you frequency of irrigation, so always remember they can ask you this in statement wise question. Frequency of irrigation निकालने के लिए irrigation efficiency की कोई जरूरत नहीं पड़ती. So if in the question they are asking you frequency of irrigation and irrigation efficiency is given, that is not required. That data is given just for confusing. Okay, so you should remember that. So in place of gamma d by gamma w, I can write porosity is 0.40 and field capacity is 0.32. Depth is 1.2. Field capacity is 0.32 minus permanent wilting point 0.1. How much it is coming, guys? Calculate how much it is coming. Does it come 0.3 meter? Just check it out once. Yes? So this will be your answer. Okay, such sort of question is there. This question I'll give you a homework. try to this simple question is there. You have to calculate frequency of irrigation. So this question I expect you guys will be able to solve it. So this question I'll give you homework. Done this question? So this question is very simple. Already such pattern of question I've already done here. So you have to calculate. See here again which data is given for confusing you guys. This irrigation efficiency is 60%. No use of this data. So it's not every time they give you every data that every data is useful. No, sometimes they give you to confuse you also. Okay, so it's not use of here. If F is dW by cu, everything else is same. Okay, nothing is different. So I guess you can do this question very well. Irrigation efficiency what? Irrigation efficiency what? Simple, huh? You can do it, right? Ayush, everybody, I think you guys can do it. So do this question. Answer is 11 days. Okay, answer is 11 days. But this question I want you to do it for confusion. Huh? Irrigation efficiency is given just for confusing you. This data is not required. ओके सो इट्स नॉट कि सब डेटा दिया सबको यूज करना जरूरी है. कभी कभी क्वेश्चंस में ऐसा होता है बट हर क्वेश्चन में नहीं. सो स्टे फर्म विथ योर कंसेप्ट्स, दैट्स इट. तो वो कंफ्यूजन के लिए दिया गया है तो ध्यान रखना इसको. बाकी कुछ नहीं है इस क्वेश्चन में. पोरोसिटी फील्ड कैपेसिटी दी अभी पिछले क्वेश्चन में ही बताया है मैंने ये रिलेशन. ठीक है. जहां पर ऑप्टिमम मॉइस्चर कंटेंट रिगार्डिंग नथिंग इज गिवन, डोंट टेक ऑप्टिमम मॉइस्चर कंटेंट, बट हियर इट इज गिवन सो यू हैव टू टेक इट. ओके. हाँ, ये तो वाला गेट का ही है. ओके, सो दैट्स ऑल फॉर टुडे गाइस. टेक केयर ऑफ योरसेल्फ. अभी हम लोग मिंटी सेशन, यू गाइस वांट मिंटी सेशन? आयुष, अरुण, सारिका, you guys want minty session because I'm planning for minty session, minty quiz for your conceptual clarity. So if you guys want, soon we'll be having a minty session, minty quiz also. Okay, so that's all for today guys. Take care of yourself. Bye bye, good night, and study hard. Minty session enhance करता competitive spirit.